All right, let's go ahead and get started. Hi, everybody. How are you all doing today? Did you all get your code review in? No. I didn't think so. All right, Project 3 has been posted. It's up on Facebook, by which I mean Blackboard. So you can look at it. It's hosted off of my website. It is a continuation of what we've been doing. You will get a whole series of files of subjects, and you'll have to take those files in, store them all, compute data over them, and then be able to pull out individual subjects, okay? So before, while we were just reading one file, this time you have to be able to accept and retain many different files all at the same time. Does that make sense? So it's posted. Go ahead and take a look at it. We'll talk about it more on next week, Tuesday. One of the things that we're going to try this semester is something called a flipped classroom model. Has anybody ever heard of flipped classroom? This is all the rage among academia these days. And part of why I have all this fancy electronic getup is because there is a grant, an internal grant on improving classes and improving teaching, which I am part of. And you are sort of my test subjects in a little bit. But the idea behind a flipped classroom is that instead of me coming in and telling you stuff and you absorbing it and going away and using it elsewhere, right? What you're going to do is you're going to do the absorption of the material ahead of time, at home, wherever you choose to do it, okay? So there is a series of lectures and a series of videos online for material that you will watch before you come to class. And then when you come to class, we will be able to do exercises and more advanced things in class. Does that make sense? Because from my point of view, everything that you're doing in here is probably pretty new to you, except for you. Everything is probably pretty new to you, but for me, this is the same thing I do every semester, right? So if I can record that once and get that once, then there's more time for me to do stuff in class where I answer your questions, where we just pick random things and learn about them and do things like that. Does that make sense? I see a lot of skepticism. Which is normal, so because it's not what we've been doing. And it's not what I've been doing, so it's new to me as well. So there's another instructor of this class, a fellow named Mark Maloof, who's put together 79 or 80 videos for different things in the class. The next topic we're going to cover is we're going to do our first flipped classroom portion. You're going to look at the videos before you come to class on Tuesday. I am going to be doing a couple of things to ensure that you're looking at the videos before class, because it doesn't do any good for me to say, look at these videos before class, and then if you show up not having seen the videos, I just have to redo everything that you would have learned in the videos anyway, right? So there's a couple of things. I'm going to be able to look through Facebook, Blackboard, whatever it is, and see who has looked at the videos or not. So, you know, a little bit of cyber big brother there. And I'll probably also hand out like an exercise sheet right at the beginning of the class for you to do to demonstrate you've done the work. Does that make sense? In future semesters, what we're going to have, and we're working on this now, is you will watch the videos, and there's going to be an online system where you will write a very small program based on what you saw in the videos and submit it to the system, and the system will grade it automatically for you. So as you learn things, you will have a chance to use them immediately instead of waiting 2 or 3 weeks till they show up on the project, and get feedback on them immediately. Then when you come to class, you can say, hey, you know there's random questions that I sometimes defer because it's too advanced. We'll just do all that stuff in class. And I'll have more advanced examples and exercises in class than we can get to in the time we have now. Does that make sense to everybody? So for Tuesday, we're going to do our first flipped classroom experiment, and I will be posting the videos for you to watch. It's a total of about 30 minutes, 35 minutes, or something like that by Tuesday. How's everybody feel about that? Who feels good? Who's skeptical? Okay. Who needs a piece of candy? So I bought all this candy for you because I like rewarding class participation. Ooh, that was a bad one. Sorry. You're in a bad seat there, Emily. I have to move. Here you go. One more. And it's in my office, and I end up eating it all. Who else? Anyone? Please take a whole lot. This is good for you. You need glucose to think anyway. This is really actually pretty fun for me to throw these things around. Anyone else? Who else? This they did not teach me. Oh, this is a heavy one. This they did not teach me in grad school. Oh, sorry. I got to find one that has a little more weight to carry that far. One more. Anyone else? I probably told you about the day someone left donuts in my classroom already. All right, so because I've had these in my office, I've been eating them all, and that's bad. All right, let's see what else. Flipped classroom. So I'm going to post the videos for the flipped classroom today, and we'll go through this, and we'll see. I think you'll notice some differences in kind of lecture and teaching style, and we'd like to later in the semester try and figure out, how this is working in terms of what you're getting out of it, and in terms of differences in, format. A week from today, we have a midterm. Anybody care to know about that? Midterm. Okay. So the midterm is going to be questions. It's going to be partially you reading through code and telling me what it does, right? It'll be like, tell me what this code prints out. Do you know how to do that? Where do you start? Start in int main and go step by step, okay? Don't try and be smart. Try and be dumb. Be dumb like the computer. Just go step by step, all right? I'm going to send out an email that has a list of topics of everything that I expect you to know for the midterm exam. I will only choose questions based on the topics that I send you, okay? So I'm going to send you a bunch of topics. It's not going to be like, something arbitrary and bizarre in there. Have you ever had professors who have done that before? They give you a list of topics and then, or they teach you a whole bunch of stuff and then view the midterm as another opportunity to teach you more stuff that you don't know, and you're supposed to figure it out, yeah. I had that too. I do not like that. So I'll have a list of topics. The other thing, and I'll see if I'll do this or not, I might just send you the entire midterm exam I've used in the past as a study guide and just write a new one. How many of y'all would like that? Okay, yeah, I thought you might. I'll think about it. I mean, what I typically do is I have like a big bank of questions and I like pick ones for the midterm, but I've used the current bank for like 10 years. And I try to come up with new exams because it's possible that you all know people who took this course in the past, and the people who have friends who have taken the course in the past before get some idea of what's on the exam and other people don't. So it's more fair if I write a new exam. The problem with writing a new exam is that when I write an exam, I occasionally make mistakes. And so after I've had a question 2 or 3 times, it's a little bit a better question because I've had a chance to fix my mistakes. Like the SATs, right? The SAT has that random section in there. So it's time to write a new midterm anyway. So anyway, so we'll see. I'll either send you sample questions or I'll just send you the whole midterm and you can see what it was like. Last year's midterm was really hard. So, and by the way, this year's midterm is also going to be pretty hard. And there's a reason for that. The reason is that I just don't like you. No, the reason is that it's better to have a hard midterm and an easy final, which is what I'll do if we have a hard midterm, than it is to have an easy midterm and then sucker people who are having difficulty into the class into staying and then crush their will to live with a final. Does that make sense? So the midterm tends to be a little more challenging than the final exam. Tends to be, judged by the average score. Yes, sir? I do not curve individual assignments. I curve the grade at the end of the semester as a whole. All right, other questions? So I will send out information about the midterm. It has some information about how you can study effectively and what I expect you to cover. Okay. Any questions about that right now? I don't know, whenever I get around to it. Probably today. And if you don't see it by like Saturday, send me an email. Yeah, I'll send it next Wednesday night, maybe midnight, 1 a.m. All right. Last time we talked extensively about function parameters. Do y'all remember what types of function parameters we had? No? A value parameter, and what was a value parameter? Essentially, it was a copy of whatever was passed into it. So if you have a function that takes a value parameter, it takes a copy. What was the other type of parameter? A reference parameter. A reference parameter you can think of being the original thing. So a value parameter is a copy, and a reference parameter is a reference to the original thing. So if you change a value parameter in the function, does it change The value where it was called from? If you change a reference parameter, the value of a reference parameter of the function, does it change where it was called from? Good. All right, so I don't know. That wasn't a good class for me, but I have a series of examples here that we're going to go through one at a time, and I just put them all on paper for you because I figured it'd be easier to go through them this way. So I'll take a second and hand these out. I'm going to leave one right here for me if you don't mind. I'll get that when I come back. Hand those down if you would. All right, in this row there should be some behind you. There was a big gap. Is there enough back there for everybody? Oh, no, we're one short. It's okay. Here you go. Here, would you like one? Anybody not get one? Anybody not get one? If you just pass the extras slightly forward. We'll get them. Okay, so I wrote 6 separate programs, and we're going to go through them one after the other and see how they work. So everybody, anybody not get one? Everybody go ahead and take like a minute and just do item number 1. Tell me what, take a second and figure out what item number 1 prints out. And you can like talk to people. You can, this is not a like quiz or anything. So. All right, who's done with item 1? Who needs more time? Okay, you have 20 seconds. All right, time's up. Who wants to walk me through this one? Nobody? All right, how about for another piece of candy? You went first. Sure. Yes?
Okay. So
Where do we start?
in main. So we declare a variable,
Uh-huh.
an integer variable x
Uh-huh.
with initial value 8.
Yep.
And then declare another integer variable y with initial value 0.
Yep.
And then we're going to do something to x,
Y equals. Uh-huh. What do we do here?
and it's a function.
Yep. What kind of function is it? Or what kind of parameter is it? Sorry.
It's integer.
Uh-huh. That's what type it is. What type of parameter is it? We have either function, value or reference parameter.
I think it's a reference.
Nope. What makes things a reference parameter? Ampersand. Does it have an ampersand here? Does it have an ampersand here? That means it's a value parameter. So cubed 8 with x. What value do we have x?
8.
Uh-huh. So what value gets copied down here into z? Does it matter that this is named z? What else could we name it? Any variable name, whatever we wanted. It doesn't matter. It would copy the value of 8 into z. All right. What calculation does it do?
It multiplies the input by itself.
3 times? Is that how you cube something? What is 8 cubed? What? Somebody said 512? 512. It's a power of 2. This is, 8 is 2 to the third. When you cube it, it's 2 to the whatever. So it's 512. So we return 512, so this whole thing there becomes equal to? And what do we do with this equal sign? What is the equal sign doing? Put 512 into y. So when we output things, what does it output? Okay. Do you all agree? Let's try it and see. It output 8 and 512. So that was correct. Congratulations. Okay. Take a minute or so and do function number 2 now. Look at item 2 and do function 2. When you're done, look bored. All right, who's ready to help us with number 2? Sure. Where do we start? We started int main. Yep, we created an integer x equals 8. I'm just repeating so it ends up on the recording. Uh-huh. Uh-huh, y is equal to 0. Uh-huh. So we call cubed. There's a parameter. What type of parameter is this? And how do you know? Because there's no ampersand in the function prototype, nor is there one in the function declaration. So we go down here, and what do we compute? Uh-huh. And it returns back here, so what does this become equal to? And it does not seem to get stored anywhere, does it? So, does this change the value of x or y at all? It does not. So when we print things out, what does it print out? 8 and 0. Do you want to test that and see if that's correct? 8 and 0. That is correct. You can compute something. The computer is happy to compute things. It's just if you don't do anything with the bit, it'll immediately forget about it. It won't cause a compiler error or anything, no. And the reason you're able to do that is because if you want to put that cubed x inside a C out, it needs to compute it, and then it will output it, but it doesn't change any of the stored stuff. The only way we change stored things is by using the equal sign or by using a reference parameter. All right, go on to the next page. Let's go ahead to function number 3. Sorry, I forgot to take my copy. Me too. I'd much rather be in there, wouldn't you? Shakespeare? All right, who wants to do function 3? Come on, somebody who's not raising their hand hardly ever. Okay. Whoops. So here are function 3. We started int main. We set x equal to 8, y equals 0. And we call, hey, this looks a little different. 2 parameters. One is a reference parameter, which we know because there is an, and one is a value parameter because, exactly. So we pass in y and x. We jump down here and, which is, yep, yep, yep. Yep. Okay, everybody get that? So here's what happens. We set up x and y. We call cubed with y comma x. Does order in the parameters matter? I mean, it matters when you go down here, but you can put any parameter in any order. There's no alphabetical or anything. So y goes into the first parameter, x goes into the second. If we go down here, we say, oh, look, y is at q. I'm sorry, y gets put into q. It's actually a reference variable. So anything that happens to q in this function will also happen to y back in where it was called from, in the main function. All right? X is a value parameter. It just gets copied over. Anything that happens to x here does not get reflected back. So we compute 512. We store it in q. Is there a return? Nope, because it's a void type. It doesn't return anything. Does cubed equal anything? Does y change? Why? I mean, why does y change? Because it's a reference parameter. So what does this print out? 8 and, do you want to test it and see if that's correct? 8 and 512. That is correct. Okay, everybody good? Let's go on to number 4. All right, who's ready to do number 4? Awesome, go ahead. Started int main, x is 8, y is 0. Yep. And x gets put into here and it's cubed. And what do we know about this parameter? How do we know that? Because it has an ampersand, ampersand. So 8 gets put into q down here. Yep. Yep. So this computes 512. 512 gets stored into q, which is a reference to x. So x also gets changed. Right, so when we output, x has become 512 because it was a reference parameter and we changed the value of that parameter down here. Y has been never changed, so it should print out 512 and 0. Shall we try it and see? Oh man, look at me, I was standing around with nothing to do and I didn't compile it. 512 and 0. Excellent. All right, go ahead and do number 5. You all ready? Number 5? We're getting into tricky territory here. Who wants to do number 5? Yes, sir. I'll save number 6 for you if you like. Uh-huh. Yep. So all this is the same int main, int xy, int x is 8, int y equals 0. So we call y equals cubed of x. So we, uh-huh. Yep. So you see that x is a reference parameter. Mm-hmm. Uh-huh. Yep. Yep. So here's what happens, right? X is a reference parameter. It's stored in the Q. Q equals Q times Q times Q, which is 8 times 8 times 8, which is, 512. So Q becomes 512. Because it's a reference parameter, it's stored back into X as 512. Then we call return 10. And what happens then? This whole thing is equal to 10, which gets copied into. So at this point now, what do we have? X is 512 and y is 10. So when we print out, what are we going to print out? 512 and 10. Oh, man. (512) and 10. All right, one more, which is a tricky one, which killed the entire class on the midterm last year. And I'll just tell you this last one is evil. Nobody actually writes code this way. But if you understand this, then you pretty much understand everything you need to understand. Okay, this is a tricky one. If you get this wrong, there's absolutely nothing to be embarrassed of. Because this is the evil professor put it on the exam trick. Nobody ever writes code like this. Okay? So, go ahead. Same thing. X is 8, y is 0. So we do x equals cubed of x. So what order do these things happen in? Right, so we cubed x comes first. X is what type of parameter? It's a reference parameter, so any changes that happen to x will be reflected back to the main program. So we go down here, x was 8, it gets copied into Q. (512). Yep. Yes, so at this point, right, we compute 8 times 8 is 512. This gets stored into Q. Because Q is a reference parameter, at this point, x also becomes 512. And then we return 10. So this whole thing becomes 10. And then that 10 gets stored where? Back into x. So it overwrites the 512 and stores 10 in there. You would have gotten full points on the midterm last year. Congratulations. Let's just see if that's actually how it works or not. So it returns 10 and 0. And this is entirely just the evil professor trick. Like I said, nobody actually changes things with a reference parameter and then overwrites it. Now, it is common to find functions that have reference parameters that also return a value. It's typical what happens is it's for things like if you have a function that does input, for example, or reads lines from a file, you use the reference parameter to capture what was read from the file, and then you return an integer that shows whether or not reading from the file was successful or not. Does that make sense? So you have a function that does both at once, but it does it for two different reasons at the same time. Okay? And that's super common to have something that has a reference parameter and something that has a return. It's just that they're never used for the same thing, except in evil professor questions like this one. All right. This is everything I could think of to step through the different combinations of reference and value parameters. We've talked about it way more than I intended, probably because I did a bad job up front. Any questions? Who says, please God, move on to another topic? Yes? Yep. Yep. Yes, so exactly. So here in int main, when it's finished, this whole int main becomes 0. It's just that we, as the programmer, don't see where that value goes. It goes somewhere, but we don't see where it goes. Does that make sense? Other questions? No. Well, yes, only for a void function. For a void function, you can have a return, but you don't have a value after it because you're not returning anything. You can use return if you want to leave the function in void. Yes, you can do that. So, yeah, I'm trying to find, like here, if we want, like here I went back to number 3 where we used a void function. If I want, I could say return here. If I explicitly put it there, it returns there. If not, it just automatically returns when it reaches the last curly brace. And if I had some sort of if statement up here, I could say, you know, like if we didn't want to cube negative numbers, if I said like if z is less than 0, we could just return without doing anything else. So it's kind of like, you know, it's kind of like a break out of a little bit like a break out of a loop. Okay. All right, you have 20 seconds to like shake yourself out, stretch for a second, and then we're going to start not a particularly new topic, but something a little different. All right, welcome back. Yes. Yes. Sure. So the question was void. So everything we've seen, every variable we've seen has a type, right? And it has int, float, bool, double, string, if stream, things like that. Sometimes a function does some work, but it doesn't do any computation to hand back when it's done. So cubed does all this work, and when it's done, it hands back an integer to where it was called from. Okay? Sometimes your function does some work, but it doesn't compute anything it needs to give back. Like, remember the first function we did, which was just to print a bunch of lines? So that doesn't do any computation. It has to return. So instead of returning a value, like a made-up value, we just use void, which means I'm not actually returning anything. Uh-huh. Yep.
Why use void?
We used void there because we're not using the return to return any value. Instead, we're passing the work we did back through the reference parameter. So So if you tried, so let me just whip up a really fast example here, right? So if I had something like, so if we had void squared and we took an int, right? And down here we did, and that needs to be a reference parameter. And down here we did, void squared, and we took an int reference parameter x, and we did, if we tried to do return x times x, the compiler should be unhappy with that. And let's just try it really fast and see. What was I calling that file? Close enough. So here, what it's saying is you have a return statement within a value with a function referring to void. And we were trying to say, look, we computed this integer, please hand it back. But because it's a void, the compiler goes, you can't, void sends nothing back. So you can only use void for things that, that don't return anything. Or you have to use a reference parameter. Okay, so it's the null type, the nothing. Void means nothing. You use void whenever you have a function and you don't need to be able to do something equals that function. Does that make sense? Okay. Sorry, take all this out. Yeah, it should be const parm, but it was perm. I typoed it, but close enough for us. Okay. So we've talked about value and reference parameters. There's two things we need to know about, other things we need to know quickly about parameters before we move on. And the first is that just like you can have constants set in your main program and elsewhere, you can have function parameters that are also a constant. All right, that are also a constant. So let's just, I shouldn't have deleted all that, I guess. Int squared takes an int. And down here we have int squared takes an int x, and what it's going to do, it's going to return x times x. And over here we can do something simple, and we can say int z equals 90 cout angle squared of z inline. So here's a pretty simple thing. We're taking some value, we're squaring it. This would look pretty familiar, yes? And here's what we can do. If we want, we can set x equal to const. We can have a const parameter. What this means is that if you try to change the value of the parameter in the function, the compiler will yell at you. If you have a const parameter, you're not allowed to change the value of the parameter. So let me just compile this really quickly. It compiles cleanly. If we run it, it squares 90 and gives us 8100, which we expect. Now, you might ask yourself, why the heck would you want a constant parameter? Is that what you're all thinking? Yes? The constant says if we try to change the value of x down here, the compiler will complain. So here we're not trying to change the value of x. Let me demonstrate. I'm a little behind on time, so I'm trying to speed up, which gets me into trouble, which means I have to slow down, and it all takes longer, so I'll just go slower in the first place. Does that sound like a plan? Okay. So here we recognize everything that's going on, right? We have int squared takes an int. We have main, we declare an int. We print out what the squared value is. Down here we say squared int, and we return that. Pretty straightforward? Okay. Now, let's say that we want to do this instead. X equals x times x, return x. Did I change any particular value here? Okay. X times x gets put into x, which changes the value of the parameter. Is this a value or reference parameter? So does it change z back here? It doesn't, because it's a value, not a reference. And when we return x, we return the thing that's squared, right? Everybody good with that? And this should compile and run just exactly as we expect. And there it is.
So the return is what makes it set equal to 100.
Yep. This return right here says wherever you see this name, this function with a parameter, it's going to assume whatever value is at the bottom of this calculation, and it's going to replace it right there. Okay, everybody good with this? Now, if we change this parameter to const, and we make x a constant, we will not be allowed to change x down here. The compiler will complain to us. God, I hope the compiler complains, because otherwise I'll look bad. Okay, and it says, hey, in this parameter, you made a parameter read only. You're only allowed to read it. You are not allowed to change it. You're only allowed to read it. You're not allowed to change it. Now, everybody good? You see the difference, what I changed there in order to get that to happen? I just put const in front of int x. We've seen const before. It means something that you're not allowed to change. Yes? We are not allowed to change the value of x inside this function because it is a constant parameter. There is a constant reference parameter, and in fact, I'm working towards that because that is pretty much the time that you want to use this. Okay? So, yes, sir? You are not allowed to change x inside this function. So if you called another function that had a reference parameter, it would complain. Yes? That's fine. As long as you do not reset x, you're allowed to do things. Yes? If to make that happy, what we would have to do is something like this. We would have to say int y equals x times x, return y. Now it's happy because are we changing the value of x in there? We are no longer changing the value of x, and now it's happy, and we run it, and we get what we expect. Okay. Do you kind of see how that works? How many of you kind of see yes? I declared y right here down inside this function, just as I needed it, because you can declare variables inside functions as you need them. So y was declared there, and we return that. Everybody with me? Yes, sir. I believe so. I just do it so when I use function prototypes, I just make them consistent so that regardless of whether you're looking at the prototype or the declaration, it's clear what's there. And we could look and see if the compiler complained if we took one away or not. But. So do you all see what we can do? We can put a const in front of a parameter, and then we're not allowed to change it inside the function. Does that make sense? How many of y'all think that makes sense? They see the mechanism. How many of y'all are wondering why the hell you would do this? Okay. Here's the deal. Typically, you do not do this with value parameters. Okay? Typically, you do not do this with value parameters. Typically, you do this with reference parameters. So let's change our function here to use reference parameters. Okay? Here we have some reference parameters, and we've referred to x by reference. Is the program going to work any differently at all now? It's not. It's going to be exactly the same thing. If I compile it and I run it, we get exactly the same thing. Now, here is why you do this. Typically, you don't do this with integers. Typically, you do this with other data variables that hold much, much more information. So let's say, for example, that we were the NSA. Have you all heard of the NSA? Anybody? And let's say that we were taking a record of every single telephone transaction that happened in the United States in a year. How many telephone calls are there in a year, do you think? Billions, trillions. There's a lot of them. Okay? So if you had a record that stored all of these things, how big would it be? It would be huge. It would be gargantuan. If we were trying to have this data and we're trying to pass it to a function that was like called, find terrorists or something, and we just passed in all the data and it looked at it to find the terrorist, if we used a value parameter, what would happen is it would make a copy of this huge piece of data. So if we called terrorist from here and we gave it that big list, it would say, okay, I have to copy this giant chunk of data from main down to our function. How long do you think that would take? If it managed to finish, if we didn't completely run out of memory and the computer caught on fire and burned to the ground, it would take a long time. So what happens is if you have big pieces of data you're moving around, you just use a reference parameter. Okay? You just use a reference parameter. Yes? Because a value parameter makes a copy from one place to the other. And if you have a huge chunk of data, like all the NSA call records for a year, there's such a big chunk of data to move around, it might take a really long time to do it, like seconds or minutes. It's a long time. Yes, and to save memory, because if you have a huge, right now in this class, we're generally not worried about how long things take or how much memory we're using. But in programs where you have a large amount of data, you have to be concerned about how long things are taking and how much memory you're using up, right? And so if you have something really huge you're moving around, you don't want to make copies of it if you can avoid it. You really don't. Yep. That is exactly it. Actually, I would like you to come up and finish teaching because you just explained it much more clearly than I did. So here's what you do is if you have a big piece of data, you use a reference parameter so that you don't have to make copies of it because copies are slow, right? And they are big and you may run out of memory. So you use a reference parameter. But what's the danger of using a reference parameter? If you screw up something in your function, it reflects wherever that thing got called from. Right? So if you have a function that takes a reference parameter and you intend to use it but never to change it, as a safety measure, you put const in front of it. And that way it keeps you from screwing up and messing up your giant chunk of data. Yeah. Yes, sort of. No, they're not. They're not interchangeable, right? Because if we put constant x down here, we are no longer allowed to change x. Const int x and int x are not the same. Const int ampersand x and int x are not the same. And the reason is if I have a function, and I'll just write another one here, it probably won't compile. But if I just write the same function the other way, inside this function, I can do x equals x times x because it is not a constant. I'm allowed to use x and change it. But if I use const x, I cannot change it. It won't change it outside the function. But the difference is that if I have the const, I am literally not allowed to change the value of x. It's not about how it works. From the rest of the program, it might look the same, but the way it's programmed is different. So, okay. Anyway, so yes. These two things, these two functions will perform exactly the same way. If we put const in there, it wouldn't compile because we're trying to change x. Const keeps you from doing x equals inside there. So we cannot do x equals down there. In this one, because it's not a const, we can. And I just put that in there and answered his question, and let's just pretend it never existed. Okay. The reason you use const is if you're moving big pieces, const int is if you're moving big pieces of data around, it's faster and you don't risk accidentally screwing up and changing data that you don't mean to change. Yes, sir? A lot of what I'm trying to teach you a lot of things. But one of the things that I like to teach you is things that will keep you from getting yourself into trouble later. And this is one of those things that helps keep you from getting yourself into trouble. You are going to use this. Yep. You are going to use this in the next project, probably. Yeah? And we'll talk about that next. Okay. Yes? If you use a reference parameter and your function is not intended to change the value of that reference parameter, you should stick a const in front of it just to keep you from screwing your own program up and having to figure out where it went wrong. Does that make sense? And I'm just trying to, I could give you just the rule when you do this, and then you would be like, all right, that's some rule, why do I care? I'm actually trying to, I don't know what I'm doing up here. Pay my mortgage. I'm trying to pay my mortgage. How's that? So, no, I'm trying to explain to you why we do that instead of just saying that we do it. Does that make sense? All right. Other questions? Here's your rule of thumb. If you're using a reference parameter and you don't want the thing that's being passed in to be changed in that function, stick a const in front of it. Okay? If you're passing very large pieces of data to a function and you want it to be fast, use a reference parameter with const in front of it. We don't care about speed in that, the speed for this class. We just don't. It doesn't matter. But someday you might be out in the world doing real things and speed will matter. Okay. Everybody kind of happy? Sort of, kind of? Okay. So that is what are called constant parameters. There is one other thing that we can do. And if you give me a second, I will write up a program about it. Sometimes we might want a function that computes something. Let me figure out how to explain this. All right, let's write this function. Pow. Who knows what pow does? Yep. This computes the power. It computes a number x multiplied by itself y times. Right? So we raise x to the y, which is the same as saying x times itself a certain number of times. So if we just want to write this quickly, we say int I equals 0, in, I less than y, I plus plus, and we say y times, we better use an accumulator, int power equals 0, power equals y, sorry. I should actually look at my notes, don't you think? Power equals x. It's a nice day today. Equals times equals x. Okay. So here's our power function. What we're going to do is we get x, which you're going to raise to the y power. We say power equals x, and we're going to loop y times 0 to y, and each time we're going to multiply power times x, so this is going to be times itself a certain number of times. Does that make sense? So let's just test it quickly in C. Int x equals 2, int y equals 4, C out, pow, x comma y. I don't know. I was going to try it and see. I have it in my notes, but I didn't actually pull it. I just figured I could wing it. So let's try it and see. I figured I was in trouble because there were a bunch of people looking up here with scrunchy eyes. So, yeah, I'm doing it one more time than I need to. You're right. So, let's do -1. So that seems better. This isn't perfect code. This is going to die under some circumstances. So, but we get the idea, right? All right. One of the things we can do with our code, and I think this is an abomination, I really do, but C++ allows it, so we're going to roll with it, is you can define a default parameter. And the way you do this is in the parameter list, you say what you want it to be equals to. So here, make this 4. We can see out let's step through this and see how this works, okay? Because it's ugly. I recommend you don't use this. There are a few cases I've seen where this was used and made a lot of sense, but most of the time, I don't like it. So we started at main, we say in x equals 2, y equals 4. We see out power x comma y ENDL. So x gets put where? Into this other x down here. Y gets put where? Into this other y down here. And when we compute it, we should be computing 2 to the 4th power. Right? And what's that going to be? So we run this, and we get 16, which is what we expect. Okay. I just commented that out for a second. So everybody with me so far? We're taking 2 and we're raising it to the 4th power. So 2 gets copied into there, 4 gets copied into there. This little loop runs, and it multiplies 2 by itself 4 times, and we get 16. Thumbs up? Yes, sir. Well, right now what's happening is this 4 is getting put in here instead of the 2. But let me show you the evil that you can do with default parameters. We can do this. Oops. And actually, the prototype has to have it as well, I think. So notice what I've done. I've changed this to say power int comma int y equals 2. What this means now is that the compiler will look for this power thing. And if it sees only one parameter, it'll go, well, I saw power. It's right up here, power, but I expected 2 things and I only see 1. Since I only have one thing, I'm just going to assume that the second one is 2 because there's that y equals 2 there. This is called a default parameter. The idea behind a default parameter is that you can specify a value for it. If when the function is not called, it does not exist, it uses that specified value. So what is this thing going to print out right here? The second line that I've added. Power of x is 2, and it says, oh, I see power, there's only this x, which is 2 in there. So I know because of this default parameter to make the other one 2, so it should print out 4. We'll compile it. Sorry, I think you only put that one place. I put it in the wrong spot. And when we run it, it does 4. Now, here's kind of what's weird about default parameters. No, yeah, I put it in the wrong place, sorry. You put it in the prototype, it does not go in the declaration. Here's what's weird about this, is it makes it sometimes really hard to match functions with which things they're going to, okay? Because of something called overloading, which we will see shortly. You can have multiple functions that have the same name, and the compiler is able to tell them apart. But it makes it hard for us to tell things apart. The weird thing about default parameters, you look horrified. I'm happy because I'm horrified too. The weird thing about default parameters is you can have as many of them as you like. If we want, we could put, up here x equals 3. And then when we call power, we can just do no parameters. And it'll look and say, oh, there's nothing in here, so I know to use 3 and 2. So that should be 9, right, if we run it. And look, 9 is exactly what it was. All of these things, pow xy, pow x, and parentheses, all refer to this function. And if you don't define one of the parameters, it uses whatever default is set in there. Yes? Mm-hmm. Okay, so here's the question. What happens now if we do something like this? So yeah, here's the weird thing about default parameters. If there's only one, it assumes that the ones on the end are the defaults, right? There's no way for us to put one thing in there and have it be the thing that we want for y. Yeah, we'd have to, if we wanted to specify y and have x be default, we would have to specify both. Right? We'd have to use both. There's no way for us to use the x default and change y because y is to the right of x. All right. I'm sorry this exists. Yeah. Yes. It's useful, but there's a difference between what's useful and what's easy to read code. Okay, this makes the code hard to read. When you look at these three things, these should look like different functions to you. And the reason is that we tell what's going on in a function by what parameters they have. Okay? And these three are actually all the same function, but they look different because they have different parameters. And it could be different. Yeah, we're going to see something called function overloading, which actually might be next. It is. So I'll use this as an instruction. Yes. There are cases where this is absolutely the right thing to do. There are times where it's the right thing to do. It's just that those times are not very common. And in general, this makes your code hard to understand. Yep. Yes. Yep. This one says take these two parameters and copy them in there. This one says we only have one parameter, so take the extra one out of y. This one says you didn't give me any parameters. I will use both the defaults for x and y. There is no way to say use the default for x but specify y. All right, everybody kind of see this? Can I show you now why this is completely evil? Would you like to see why this is evil? So one of the things about functions is, let's say that we also wanted to be able to compute the power of something that's a floating point number. Okay? We can do that. And we can write a function that has exactly the same name, but different return types. And here's how I'm going to write this function. I'm going to do this. I'm going to copy the same function. I'm going to change all the x's into doubles. Oh, except for this one, because the loop needs to be. This now computes the power for floating point numbers, right? Because floating point numbers are handled differently than integers, aren't they? Now, you might do something like, we might want to do things like call this one power int, and we might want to call this one power float or something like that. But that would be horrible, because as a programmer, you would have to, you couldn't just use what came naturally. You would have to look and get the right function for each thing. So what C++ allows are functions that have the same names as other functions. And this is called overloading. Okay, this is called overloading. So now we have this other function that instead of integers takes floating points. It does the exact same computation, as an integer would, but it uses floating points instead, right? Yep.
Wait, so what's overloading?
Overloading is using the same function name for different functions. Overloading is using the same function name for different functions. So let's go back. Do you see we have these two functions here? One that does ints and one that does doubles, but other than that, they're exactly the same? Yeah. I have changed nothing up top yet. All I did was add the function prototype for the other one. I haven't changed anything up top. But do you all see we have these two functions? One works with ints and one works with doubles, right? Thumbs up, thumbs down. Everybody lost their thumb in an accident. Who's with me? Two functions. Who's against me? That guy's gone today. So, all right. So my question is now when the compiler runs, it says, oh, cout pow xy. Which one of these functions is it using? They have the same name. Which one is it using? How? How do you know that? Exactly. When functions have the same name, but different types of parameters, it looks at the parameters that are put in there to figure out which function to use. So x is a what? And y is a what? So we look and we go, oh, here's a function that says pow x and y. Those are both ints. I probably should use that one. Yep. You can stick a literal in there. That's fine. Yep. It would recognize the type of the literal as an integer. Yeah. And if you needed to make it a float, you would type 2.0. You'd make it a double literal. Okay. So here's where it gets confusing, right? Here is why I don't like default operators, because we could declare as many different functions as we wanted using the same name, and the compiler tells them apart by looking at the number and the type of the parameters it receives. Does that make sense? So function overloading is when different functions have the same name, but they have different parameters. They have different parameters. So let's see if this compiles. It should. It's fine. And if we want, we can do some computations, some double computations, right? We say something like double G equals 3.14, double E equals 2.718281828, right? And now we can output, if we want, what e to the g to the e pi. Let's just call this pi. Why are we beating around the bush? All right. So if we want to see what pi to the power of e is, we can compute that. Yeah, because my loop is wrong. I told you there were some problems in the code. I should have come up with a different example, but we'll just pretend it's right, okay? So, see? 31.063. Close enough. Pay no attention to the giant mistakes I'm making up here. But you see what we're trying to do here, right? Yes? Yep.
But so my question is like, can't you like 4 is an integer, but technically isn't also a float?
Yeah, the way you tell them apart. So here we can do this, right? What I'm gonna do is I'm gonna put an output statement in here. That just tells us which one got called, okay? See, that one says integer power, and this one down here will say the buggy double, I can't type now, double power. So now we can tell them apart when they run. So I'll compile, I'll run. This one was integer power, that one was integer power, that one's integer power, that was the buggy double power. So your question then is, what happens up here if we start sticking literals and things? So say we do cout angle 2, 4. Oh, I forgot the pow. Which one is this going to call? It's technically an integer. It's actually not just technically an integer. It is absolutely technically an integer, right? If we call it, it's going to say, look, integer power 16. Well, let's try it and see. So if we put 2.0 and 4.0, which one's this one to call? You're absolutely right. It's going to call the double. I bubbled. Oh, sorry, fat fingered it. If you ever have a fear of public speaking, you should try public typing. It's really wacky. Okay. So it called the double power. Now, what happens if we try and mix the two up? All right, so if we put 2.0 and 4, what's this one going to do? It's going to what? It's going to barf. It is, right? And the reason it's barfing is it says, look, you told me about a function that takes two doubles. You told me about one that takes two ints, but you didn't tell me about one that takes a double and an int. I don't know about that. Okay. Well, yeah, it's because we don't have a matching function prototype is why it's dying. All right, so that's function overloading. Yes? No, the return type doesn't matter actually, because it can't. Well, I don't want to commit myself to that. So we'll look next time. It's possible for the compiler to like look and see what it's being put into and see if it was the right return type and pick that way, but I don't know if it does or not. So that's my answer. All right, have a good weekend. Enjoy. Take a look at Project 3. I will send you email when the videos for the next class are up for you to watch, and then we will start flipping the classroom around a little bit.